Hello, thank you so much for click this video. My name is Alifia Alvarez from Environmental Engineering Batch 2023, and here I am will present about my final exam assignment of chemistry that given by my lecturer, Ma'am Temmy Wikaningrum. So for Ma'am Temmy, thank you so much for giving me the opportunity to make this video presentation. So for this presentation, my topic is green chemistry. When we say green chemistry, we mean environmentally friendly chemical process and doing chemistry with personal safety and the environment in mind. Okay, before we continue to the more detail of this topic, I'll tell you about the meaning of green chemistry itself. So, green chemistry refers to the design of chemical products and process that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycles of chemistry product, including its design, manufacture, use, and ultimate disposal. Okay. We continue to the principles of green chemistry. So, green chemistry itself has 12 principles. There are prevent waste, atom economy, less hazardous synthesis, design benign chemicals, benign solvent and auxiliaries, design for energy efficiency, use of renewable feedstocks, reduce derivative, catalysis, design for degradations, real-time analysis for pollution prevention, and the last is inherently benign chemistry for accident preventions. So, there are designed to help make chemistry greener. We will discuss each of these principles with an example. But I explain with example because we often encounter them in everyday life. So let's start with a simple concept. For topic number 1 is how can we prevent waste? So for the simple concept, if you keep your room neat and tidy, you won't have to clean up as much. If your room gets messy, then you will have a lot to clean up. The same concept is applied in green chemistry. If we prevent waste from being produced, then there would be less to clean up. Now, this is almost impossible to have zero waste for any given chemical reactions. On a global scale, the beauty of these principles is that it can be applied to almost every single chemical reaction conducted. For example, polystyrene. Polystyrene is a fossil fuel-derived polymer used to make all disposable cups and packaging materials. The polymer itself needs to be expanded before it can be used in packaging. Traditionally, this was done with CVSCS, which deplete the ozone layer. Now, this is done with carbon dioxide waste from other industrial processes instead of releasing carbon dioxide into the atmosphere and contributing to the greenhouse effect. This is contained and used to expand polystyrene. So, there is no additional carbon dioxide being released into the atmosphere. Okay, back again with our topic. How can we prevent waste? So there are 3 points to prevent waste. First, it is better to prevent the formation of waste than to treat or clean up the waste. Then, chemical wastes are undesirable products from chemical reactions. They are usually hazardous to the environment. And the last is industrial process should be designed to minimize the generation of waste. Okay, so we go to the next topic of the principle of green chemistry. The second principle is atom economy. Where is atom economy? So, atom economy means maximizing the incorporation of material from the starting materials or regions into the final products. It is essentially pollution prevention at the molecular level. Okay, next we have less hazardous synthesis. The next time you look at tight certain paints or even plastic used in window frame, you may want to think about the raw materials from which they are made. Do you know any of these materials? So, all these materials require adipic acid in their production. Usually, benzene is used to make this compound, but unfortunately, benzene is carcinogenic or cancer, causing instead glucose and a special enzyme extracted from genetically modified bacteria can be used to produce adipic acid. What do you think is the advantage in doing the synthesis in this way? An answer is that glucose is harmless and is essentially sugar, so conducting the synthesis in this way protects the workers. The workers who would produce this compound by coming into contact with carcinogenic benzene. So, point number 4 is design benign chemicals. What's the meaning of design benign chemicals? So, design benign chemicals is the process of creating chemicals that have minimal or no harmful effect on human health and the environment throughout their life cycle, including manufacturing, use, and disposal. So, this principle encourages the design and therefore the use of less hazardous or toxic chemicals. In research in chemical industries, drug developers always look towards using chemicals that are chiral. These are molecules that have a particular shape. This minimize the unwanted side effect that some drugs can have. Think about it like a pair of gloves. The right hand glove can only fit over your right hand, and the left hand glove can only fit your left hand. Drug industries try to produce medicines whereby 100% of the drug produced in chiral. This fulfills another rule of green chemistry by minimizing the amount of unwanted products, i.e., drugs that have the wrong chirality. Carefully tweaking part of a drug's design can also be useful, as drug designs can be used to target specific organ, making the drug less likely to have unwanted side effects. So, next we have benign solvent and auxiliaries. What is that? So, this is chemicals or substances that are environmentally friendly, non-toxic, and safe for human health. They are used in various industrial processes such as cleaning, manufacturing, and synthesis, where traditional solvents and auxiliaries may pose risks to the environment or human health. Design for energy efficiency. Many chemical processes are designed to be as efficient as possible. There are many reasons why this is done. Firstly, it is very costly if a chemical synthesis is not designed to be efficient in industry. Chemists are aiming to modify or develop reactions so that they'll process at ambient temperature and pressure. This is because it costs energy to produce both high and very low temperatures. The 2005 Nobel Prize for Chemistry was jointly awarded to a group of chemists who developed an energy efficient catalyst for a high atom economy reactions, so that it was able to process at standard ambient temperature and pressure. Recall that a high atom economy reactions is one that uses all the atoms in the reactant to create the product, or products. The reactions is called the metathesis method and is responsible for the synthesis of many polymers with special properties adaptive to polymers and fuels and biologically active compound. For the simple meaning is energy requirement should be recognized for their environmental and economic impact and should be minimized. Okay, next is use of renewable feedstocks. It means as both a raw material and a fuel source in manufacturing. As a raw material, it's often used to synthesize environmentally friendly new products like biodegradable plastic. So far, many of our plastic products are derived from crude oil, which is a non-renewable source. We cannot grow or produce crude oil. This means that we don't have an infinite supply of it. Instead, we must wait millions of years in order for that carbon-based living organism to be compressed by layers and layers of sediment before we get crude oil. The term renewable feedstocks refers to raw material that can be grown or produced by humans. The usage of renewable feedstocks is attractive because it reduces the amount of harmful waste produced from the crude oil refinery and distillation process. Most printer inks are made from crude oil derived pigments. If you think about the amount of printing that is done on a global scale, this can be a problem the long term. Currently in development are soy-based inks, which are derived from the oil of the soybean plants. As a plant soybean are a new renewable resource, the production process of these inks is overall more environmentally friendly than their petroleum-based counterparts. Also, these soy-based inks are much brighter than the petroleum-based inks. The recycling process of paper products print with soy-based is also considerably more environmentally friendly. When paper products are recycled, the ink needs to be removed. Petroleum inks can be difficult to remove, but soy-based inks can be removed with relative ease. Next, we talk about reduced derivative. So, reduced derivative means minimizing or eliminating the use of derivative chemicals in chemicals process. Derivative chemicals are those substances which are derived from another substance through chemical reaction. And the next principle is catalysis. Catalysis is the chemical product design and process which eliminates and reduces the usage and hazardous substance generation. And then in green chemistry, we have design for degradation. Design for degradation means chemical products should be designed so that at the end of their function, they break down into enhanced degradation product and do not persist in the environment. Okay, next we're gonna talk about real-time analysis for pollution prevention. As we know, one of the biggest challenges that chemists face is knowing what impact their synthesis is going to have on the environment. Monitoring a process on a small scale to see what pollution is produced at a particular stage of a reaction can reduce the pollution that produced the large-scale synthesis. An answer might be that looking at the pollution produced on a small scale and real time will enable chemists to know where they have to change in their large-scale synthesis to ensure their practice have a lower environmental impact. And then the conclusion of this principle is the use of analytical techniques to monitor pollutant in the environmental in real time. This information can be used to identify source of pollution, track the movement of pollutants, and develop strategies to reduce pollution. Okay, for the last principle that we're gonna talk about is inherently benign chemistry for accident prevention. This is a substance, and the form of a substance used in a chemical process should be chosen to minimize the potential for chemical accident, including release, explosions, and fire. This principle is specifically about the avoidance of using or producing hazardous compound. The area of avoiding hazards can be extended to other areas of the lab. Storing chemicals that are reactive together, such as oxidizers and flammable materials, leads to a risk of release and reactions. If these compounds leak from their containers and react, they will create a large fire. This is a hazard that could be easily avoided by storing these chemical types separately. Okay, finally, we're done about 12 principles of green chemistry. So, after we discuss about the principles of green chemistry, I'm gonna tell you about the example of this topic. So, one of the example of green chemistry is replacing a hazardous sorbent chemical used to capture mercury from the air for safe disposal with an effective but non-hazardous sorbent. Using the non-hazardous sorbent means that the hazardous sorbent is never manufactured. And so, the remediation technology meets the definition of green chemistry. So, yeah, for our last discussion in this topic is the benefit of green chemistry. And I already make 8 key points of the benefit of green chemistry. And yeah, let me tell you. So at the first we have reduce pollution. Why reduce pollution can be benefit of green chemistry? Because green chemistry aims to design chemical products and process that reduce or eliminate the use and generation of hazardous substance. This leads to decreased pollution of air, water, and soil. And then second, resource conservation. By using materials more efficiently and minimizing waste, green chemistry helps conserve natural resources. This can include the efficient use of raw materials, energy, and water. And then healthier product. Green chemistry promotes the development of safer chemicals and products. By minimizing the use of toxic substances, it reduces health risks to humans and other organisms. Cost saving. Why cost saving? Because implementing green chemistry principles can lead to cost savings for industrial through improved efficiency, reduced waste disposal costs, and the use of less expensive and hazardous materials. And innovation. Green chemistry encourages innovation in chemical research and development. Finding alternative, more sustainable ways to produce chemicals can lead to new discoveries and technologies. And we have regulatory compliance and enhanced reputation, and the last is global impact. Why global impact? Of course, there are reasons. So green chemistry can contribute to global efforts to address environmental challenges such as climate change, biodiversity loss, and pollution. By reducing the environmental footprint of chemical process and product, it helps mitigate these pressing issues. After I tell you about the benefit of green chemistry itself, of course, we as students has a benefits to studying green chemistry, both the society and the environment. There are environmental preservation, healthier communities, resource conservation, economic benefits, innovations and competitiveness, global sustainability, policy support. And finally, we go to the last part of this video. I hope this presentation can help you to more understand about the green chemistry and you know more about the 12 principles, the benefit, example, and of course the meaning of green chemistry. So yeah, I hope this presentation was useful in your daily life and thank you so much for watching. Goodbye. It's the sun.